And welcome to my YouTube channel. So today in this video we are going to discuss about the mirror formula and then we'll discuss about magnification. Now these two topics are very important for doing numericals, especially for class 10 students. So before I start this video, I would like to request everyone to please do subscribe and share my videos, because most of the viewers have not subscribed my video. So please do subscribe my video and also do share it with your friends so that it may help them to prepare for their board examinations. So with this, I'd like to start my video. So today, the topic that we are discussing is mirror formula and then magnification. So in class 10, this derivation is not there. So you just have to remember the formula and you have to apply this formula to solve numerical questions. So here students, they find difficult to solve the numericals. Numericals is a huge task for the students. So I would like to simplify this so that you can score marks by doing the numericals also. So here in the board you can see the formula, which is called as the mirror formula, and the relation is between the focal length, object distance and the image distance. And the relation is 1 by f is equals to 1 by v plus 1 by u. So here the first thing that you have to know is the terms. So u here stands for your object distance, v stands for your image distance, and f stands for your focal length. Now I have already discussed all these terms in my previous videos, so you can go and do check that videos so that you can have idea about it. Anyways, let me briefly inform you. Object distance means the distance of the object from the mirror, from the pole of the mirror to be precise. So we are discussing spherical mirrors here. So the distance between the object and the pole of the mirror, we call it as object distance. Image distance is the distance of the image from the pole of the spherical mirror, and focal length is the distance between the pole of the mirror and the focus. So these are the three terms that you have to remember here. And while doing the numericals, we need sign convention. So for sign convention also, I have already made videos for convex mirror as well as concave mirror. So please do check that videos and then we can solve numericals. Don't jump to this video directly, because you need the concept of sign convention, you need the concepts of the terms that we use in spherical mirrors. So please do check that videos and watch the videos completely. Only then it will be helpful for you. So the next term that is important is magnification. So magnification can be defined in two ways. Alright, so here you can see the equations. Magnification, first of all, the symbol is small letter m. So m represents magnification, and magnification can be defined as hi upon ho, where hi is the height of the image, ho is the height of the object. So the ratio of height of the image and the height of the object, we can define it as magnification. Sometimes the symbol used for height of the image is simply I, and height of the object is represented by O. So don't get confused with the symbol. It can be anything, hi, ho, or it can be I and O, but the meaning is same. Here I stands for height of the image or image height, O stands for object height. So the first definition will be the ratio of height of the image to the height of the object is defined as magnification. The other definition for magnification can be V divided by U, where V is your image distance and U is your object distance. So magnification can be defined as the ratio of image distance to the object distance. So these are the two formulas, or these are the two definitions for magnification. Now since magnification is the ratio of two similar terms, the thing that you have to remember is it does not have any unit. Height of the image, height of the object. So ratio of the same terms or same quantity. So the ratio unit gets cancelled. So it does not have any unit. Similarly here, image distance, object distance. So the unit gets cancelled. So magnification does not have any unit. Now while solving the numericals, apart from this, we can also write the third formula, which comes from the first two formula itself. As you can see, in the first and the second equation, left hand side is same or equal. So whenever left hand side is equal, right hand side has to be equal. So if we take that into consideration, then we can write the third formula which we can use while solving the numericals. It's not a new formula, but it comes from the first and the second equation. Alright, since left hand side is equal, right hand side has to be equal. So we can write this as HI upon HO is equals to minus V upon U. So these are the three formulas that we need for magnification to solve the numericals. So remember this formula, M is equals to HI by HO, height of the image by height of the object, or if image distance and object distance is given, then ratio of image distance by object distance is also magnification. And sometimes the combination of these two we have to use while solving the numericals. HI by HO is equals to minus V by U. Since left hand side is equal, right hand side has to be equal. So these are the three formulas. Now this is important, so you have to note this down. So some of the things that is related with the term magnification. So while doing the numericals, they don't give the values directly or the sign directly. So reading the sentence, sometimes you have to see which sign is or has to be used. So if M is negative, then you have to know that image is real and inverted. So whenever we have a real and inverted image, then M will be negative. M is the ratio of height of the object and the height of the image, or height of the image and the height of the object. So we have already done this sign convention in the previous videos. So for real inverted image, the image is formed below the principal axis, for which the sign will be negative. So because of that, M will also become negative. So you have to remember, if M is negative, image has to be real. So this one is important. Similarly, if M is positive, if the value of M is positive, then you have to understand that the image formed is virtual. Again, for virtual image, the height of the image and the height of the object both has to be above the principal axis. So then we get M as positive when we take the ratio. So this one is also important. For a virtual image, you have to take M as positive. So these 2 points is very important, because while doing the numerical, they will only say the image formed is real. So there you have to take the sign as negative for M, and if the sentence says the image formed is virtual, then the sign for M has to be positive. Now the other things, if M is equals to 1, then we can say that object and image formed are of same size. For example, magnification is the ratio of height of the image and height of the object. So here, if HI and HO are equal, HI is equals to HO. So instead of HO, we can write HI in the denominator. So if you cancel these two, you will get 1. So whenever your image height and object height is equal, the value of magnification will always be equal to 1. And this we can see in case of a plane mirror, where image and object are of same size, and also for a concave mirror when the object is at the center of curvature. For object at center of curvature, for a concave mirror, image and object are of same size. So in that case, the value of M will be always equals to 1. So that means height of the image is equals to height of the object. So this they can ask you in the objective also. If M equals to 1, then what does that mean? It means that image height and object height are same or equal. Now, the fourth case, M is greater than 1, means image is magnified. The image formed is larger than the object. For example, in this case only, if we take HI is equals to, let's say, 2 times HO. That means height of the image is twice of height of the object. Then here we can replace, HI as twice of HO, and in the denominator we have HO. So if you cancel HO here, then we'll get 2. Now 2 is greater than 1. So whenever image height is greater than the object height, the value of M will always be greater than 1, which means that the image is magnified or image is larger than the object. And the last point here, if m is less than 1, then we have to understand that image is diminished, or the size of the image is smaller than the size of the object. So let's consider the case here. So let's say the height of the image is height of the object, let's say, is twice of height of the image. That means here image height is smaller than the height of the object. So if you put this here in the formula, then we get hi. Ho can be replaced as h twice of hi. So hi and hi gets cancelled. We will get 1 by 2, and 1 by 2 is nothing, it is 0.5. So which means the value of m is less than 1. So whenever image is diminished or size of the image is smaller, the value of m will be always less than 1. So these are few points that you have to remember, especially the first and the second point for doing the numericals. Alright, so further information on magnification. So magnification of a plane mirror is always +1. I have already explained that a plane mirror always forms the image same as the object. That means height of the image and height of the object will always remain same. So when you put the value in the formula, m is equals to hi by ho, then the value will always a positive number and equals to 1. So if the question says a mirror forms an image for which magnification is always +1, then the mirror will be a plane mirror. Similarly, if we take a convex mirror, then the value of m will be positive. Now value of m will be positive because convex mirror always forms image behind the mirror. It is a virtual image, and for virtual image m is positive. And if you look at the value of m, then for convex mirror the image size is always less than the size of the object. So for that I have already done the video. You can go and check image formation by a convex mirror. So there you will see that image formed by a convex mirror is always virtual. That means m will be positive and size of the image will be diminished or smaller than the size of the object. So it will be always less than 1. Similarly for a concave mirror, now concave mirror has one special case. So for concave mirror, m is negative. Now why m is negative? Because concave mirror forms real and inverted image, and real and inverted image is formed in front of the mirror. So m will be negative in almost all the cases. But when the object is between the pole and the focus, concave mirror forms a virtual and erect image. So that is one special case. So when the object is between the pole and the focus, then the size of the image will be magnified. So for that case only, the value of m will be positive, and also the value of m will be greater than 1. So this is the only case where a concave mirror has magnification positive and the value is greater than 1. For rest of the cases, m is always negative. So depending on this, you may get some objective questions. And for image formation by concave mirror and convex mirror, you can go and check the video, watch the video in detail, go through it thoroughly, and then you will understand these points better. Now if you understand these things, then solving numericals will become easy. So in the next video we will solve numerical questions. So for that you have to be prepared with the sign convention and the formulae and whatever important points that we have discussed. So please do watch previous videos and then you can solve the numericals. So with this I'd like to end my video. Please do like, share and subscribe my channel, and I'll see you in the next video. And please do comment and give suggestion for improving my videos. Thank you.